Everyone. I am Harshini. I am currently pursuing my bachelor's in AIML at Nitya Meenakshi Institute of Technology. I am going to present my project on landmark recognition using AI. Suppose if you are planning for a trip to any monument or you just come across a random image in social media or any other website, we all would want to know what it is about. We want to collect information. Though there are many existing tools that might give you information, but you would have to switch between various applications and you would have to, if you're using any chat GPT or any other AI assistant, you would have to ask many follow-up questions to get precise and concise answers. So there is a need of a single integrated system that provides you essential details along with some tourist details. And that's why to address this problem, I have developed a Indian landmark detection system using AI. So let me just brief you out about the model that I have used. To train the model, I've used the Indian monument dataset from Kaggle. This dataset has around 4,000 images in total. And 23 train monument classes, which covers all over India, the main monuments in India. So this is the count of each of the classes, each of the monuments. There were around 4,000 images in total. I have used 3,000 images for the training and 1,000 images for the testing. Out of the 3,000 images for the training, I have divided it into train set and the validation test to check the accuracy. So moving on to the data pre-processing. Since deep learning models required images of the same size, I have resized the images to 242 and into 242 pixels, and also I have applied data augmentation techniques that would alter the images, existing images, like flipping it or tilting it, so that model will be able to generalize well and predict in any various conditions. So here you can see the images. The images are tilted a bit, the brightness is increased. This was about data pre-processing. Now coming to the model that I have used DenseNet 121. It is a pre-trained CNN model. Instead of developing a model from scratch, I have used a transfer learning. This model is being trained on ImageNet. So I have used the already pre-trained weights. And along with that, in the classification layer, I have added an extra layer. Like I have used global average pooling to reduce the extracted features, and then ReLU activation to enhance the pattern recognition of the model. And also I have used the softmax for the final classification. This was my initial model at the first. Then I began fine-tuning it to improve the model further. So then let's see the results of the model. So this was the training. Here you can see the confusion matrix. The diagonal elements represent the exact monuments that the model has to predict correctly. Most of it lie along the diagonal. So the model gave an accuracy of 96%, which was perfect, which was neither overfitting nor underfitting. This is the classification report, which shows the precision accuracy, and it achieved an overall accuracy of 96%. This is the accuracy curves after the fine tuning. Here you can see the accuracy curve, and this is the loss curve. Here we can see that both the training and the validation achieved an accuracy of 96%. And coming to the loss graph, both of them converge at exactly the same point, which refers that there is no overfitting. Then this was about the model. Then after developing the model, I put it in the Google Drive, and then I've used it with combining with web development, and I have made the web application. So this is the user-friendly interface. When you click Explore Now, you get an interface where you can upload any image. The image can be of anything, like suppose the monument, it doesn't necessarily mean that you have to upload the exact front image or the back image. So for example, I'm uploading an image. This is not the front of the temple or the major view of the temple. This is in the interior of the most famous temple in Tamil Nadu. So let's see whether if it identifies it well. I'm giving identify monument. This is Tanjavur temple in Tamil Nadu. And when you go below, story, this gives you a brief idea about the history of the monument. And this is the major architectural highlights. This gives you about the Dravidian architecture, the builder, the dynasty, and also other tourist details like timings, entry fee, and the best time to see the location. And this section gives you the specialty of that monument. And here you can explore the different views of the monument. The system also integrates the location, so you can see exactly the location of that monument. It is integrated with Google Maps. So I'm clicking here, open in Google Maps. While it's still loading, let me show you the last feature, the AI Heritage Guide. This is a Gemini, LLM-based Gemini integrated. So you can also ask any other extra information, whether if you want to know anything. So before that, yeah, the Google Maps have loaded. Here you can see this is the location of the Tanjavur temple, and the exact location you can get to know from your current location. Now, going to the LLM. Now let me ask a question. What are the nearby attractions? You can see the result has been come here. It gives you the 5 major nearby places, tourist attractions. This has been done by integrating Gemini Flash 3.6. So this was all about my project. This combines computer vision, LLMs, and to make your heritage exploration easier. Thank you.